Hi guys, this is Maths Tuesday, the 26th of January. We're carrying on with our division work today. However, I said yesterday it was a bit more problem solving, and it is. So this is one of my favourite ways of problem solving this. So I'm hoping you'll really enjoy today's lesson. Your LO is to find all possibilities. It will include some working systematically, which we've done before in a couple of weeks ago, I think, on home learning. We worked systematically to try and solve a problem, which means we used a system. So we'll start off that way, and then we'll look at how we can bypass the system to do things more quickly and effectively. So for your recap today, just some things to get our brains going, get our brains started, and to think in certain ways. So pause the video and try this recap. I can also read out each question if you prefer. So question 1, count up in fours from 4 to 40. Pause the video now and write out your 4 times tables from 4 up to 40. Right, your times tables from 4 up to 40, if we're counting in fours: 4, 8, 12, 16, 20, 24, 28, 32, 36, 14. For those of you that I know that are out there that would have gone a little bit further, 44 and 48. Number 2, complete the repeated additions. Pause the video now and try these questions. Okay, so you could sit there and do 3 add 3. I'd be inclined to count. So 3, 6, 3, 6, 9, 3, 6, 9, 12. Much quicker than trying to add on 3 each time in your brain. Complete the multiplications. So you can pause the video and try these. Okay, so you could sit and work them out each time. What you may have seen is that it was 8 times 1, times 2, times 3, times 4, times 5, times 6. That pattern shows me it's 1 or 8 each time, so I'm inclined to count. 8, 16, let's type this because this is a nightmare. 8, 16, 24, 32, 8, 16, 24, 32, help me, 40, 48. There we go. My brain needs to wake up. Okay, so tick those ones. So using your times tables and being really secure with your 3s, 4s and 8s by the end of year 3 will help you to answer questions like this super quickly and super easily. Okay, new learning. So the children are dressing the snowman. They have 3 hats and 2 scarves to choose from. I can see a blue hat, a green hat and a pink hat, and I can see a green scarf and a blue scarf. Now, how many different combinations could they have for their snowman? So we can try working systematically for this. So I can see that there is a blue hat here. So that blue hat could go with the green scarf, or that blue hat could go with the blue scarf. Then you might want to pause the video now and draw out this table, and you might know how to do this for the green scarf, the green hat and then the pink hat. So feel free to pause now and try it, or you can watch along this time. So there's a green hat, which I know could go with the green scarf. There is a green hat, which could go with the blue scarf. Would go with the green scarf, or there is a pink hat which could go with the blue scarf. So those are all the different possible options. But let's look at how to answer this question when it says how many different combinations could they use. So I know which ones could go together, but if I look at this, in answer to that question, how many different combinations are there? Well, here they all are. These are the ones I've just written out, but they're here now. And you can see I've put them into blue with green and blue, green with green and blue, pink with green and blue. Now, Sam thinks that there are 6 possibilities, but Alice thinks that there are 12 possibilities. Pause the video. Who do you agree with? Okay, so I can see that for the blue hat, they could have had green or blue. So that's 2 different options there. 1, 2. The green could have had green or blue. That's 2 different options there because 1, 2. And pink with green or blue, that's 2 different options there for the pink. 1, 2. So that's 2 for blue, 2 for green, 2 for pink, 2 add 2 means 6, or 3 different colours with 2 different options. So 3 times 2 is 6. So in answer to this question, how many different combinations? Well, there's 1. Ooh, how many different combinations? There's 1, 2, 3, 4, 5, 6. 6 different combinations. Now, Alice thought that there were 12. Pause the video. Why do you think she thought that? Okay, so Alice might have thought that there were 12 because as well as there being 1, 2, 3, 4, 5, 6 different options, she might have seen these as more options too and might have thought, well, there's 12 boxes here because I can see 4, 8, 12 boxes. So maybe there's 12 different possibilities. But actually it was about the pink hat being with the green scarf or the pink hat being with the blue scarf. So there were only 6 different options. It's just something to watch out for. Okay, now I wonder if we can solve this without using a system. We'll see. What if they have 4 hats and 3 scarves to choose from? How many different combinations could they use? Now feel free to draw out that table with hats and scarves, and you might choose to start popping down all the hats and the different scarves they could have. So if you want to do that, pause the video now and you could use that system. Okay, so you could have the blue with the green, the blue with the blue, and the blue with the yellow. So this is talking about the blue hat with green, blue, or yellow scarves. There's 3 different options there. They could have the green hat with the green, blue, and the yellow. So there's 3 options there. They could have the pink hat with the green scarf, the blue scarf, or the yellow scarf. So there's 3 options there. Or they could have the grey hat with the green scarf, the blue scarf, or the yellow scarf. So there's 3 different options there. Okay. Now, this system can prove that to be true, but we could have actually done this without that system, because what I see here are 4 hats. 1, 2, 3, 4. And for each hat, there were 3 different options of scarves. So I can see 3 scarves and 4 hats. So all I would need to do is think for each hat there would be 3 scarves they could choose. So that's 3, add 3, add 3, add 3 for each of the hats. So that's a blue hat that's got 3 scarves, a green hat that could have 3 different scarves, a pink hat that's got those 3 different options, or a grey hat that's got those 3 different options. To make that quicker and easier, I could do 4 times 3 is 12. So using those 4 hats and those 3 scarves, I can think, well, I've got 4 hats that could each have 3 scarves. So very quickly and easily, without having to use that system, there could be 12 different options available. And I can use the system to prove it, but I didn't need that to work it out. So if I look at that system, there's 3, there's 3, there's 3, there's 3. So that is showing me 1, 2, 3, 4 times 3 equals 12. So if we go back to our new learning now, we can see that with these hats here. I had 3 hats, 1, 2, 3. And I had 2 scarves. So 3 hats that could have had 2 different scarves. 3 times 2 gave me the answer of 6. Now you can start to see we don't have to do the table. So here is your apply question. Whitney is choosing a piece of fruit and a drink. How many different possible combinations are there? Oh, that's annoying. It's got the answers right at the bottom. Okay. Either pretend you didn't see it or prove it now on your piece of paper. Whoops. Sorry, everybody. So, looking at that now, Whitney's choosing a piece of fruit and a drink. How many different possible combinations are there? So, look at how many pieces of fruit are available, look at how many drinks are available, and what times table question could you use to prove that? If you want to do the table with the 2 different drinks and then all the pieces of fruit that they could have as a choice, by all means do that to prove it, but try to start moving away from that system to get your answer. Use it to prove it instead. Okay. Okay, so here we go. I'm hoping you've paused the video by now. If not, pause it now and try that problem. Sorry, so I can see there are 2 different drinks. Now for each drink, so say if I chose this one, there's 4 different pieces of fruit I could choose. So for each drink I choose, there's 4, what is going on? there are 4 different pieces. There are 4 different pieces of fruit I can choose, because I could view that as 4 different pieces of fruit for that one. Add the 4 different pieces of fruit that could also go with that one. So I could view that as 4 add 4, or I could do it as 2 times 4. So the total possible combinations, there are 8 of them. Okay. Okay. So this one, don't worry, I haven't revealed an answer. It's meant to be there. Right. Going a bit deeper. So if you're feeling quite confident with this, let's look at how we can work backwards. Dexter is choosing an ice cream. He chooses 1 flavour of ice cream and 1 sauce. There are 8 different ice cream flavours. How many different sauces are there? And your clue is that there are 24 different possible combinations. So when they've done whatever they've done to work this out, whatever times table question they managed to combine, there are 24 different possible combinations. So it's equal to those 24 options. Now, if we look back at the question, you will see how many different ice cream flavours there were, and there were 8. But each ice cream flavour could go with a different sauce, so you just need to work out the value of that missing number. Pause the video now and you can try that. Okay, so it's like working this out. 8 times 1 would be 8, 8 times 2 would be 16, and from your recap, 8 times 3 is 24. So that missing answer, there would have been 3 different sources to give you those 24 options. Okay, that is today's math lesson. Hope you enjoyed that. I will look out for your work today, so hand it in via Teams, or you can email it to us. I know a few people are starting to prefer emailing it to us now. Honestly, it's whatever works for you. It's however you would choose to hand in that work. It's up to you, whichever makes it quickest and easiest. Okay, so I will see you tomorrow, guys, back here for some more problem solving and division.